So my research area is knowledge-based systems. The question we are asking there really is how human knowledge can be represented and be used in computer systems to solve real problems. Of course, today, if you think about how we use computer systems, we can easily represent large amounts of human knowledge, if you think of Wikipedia, for example. But computers cannot really use this knowledge to solve difficult problems today. And conversely, we also have computers which are great at solving hard problems, for example, playing Go or playing chess. But these computers cannot explain us how they actually managed to be so good in these games, for example. So the question we are really asking is, how should we represent knowledge so that both computer systems and human experts can work with it and interact? Now, this field is really a cross-disciplinary field which involves artificial intelligence and databases, web information systems, and a lot of mathematical logic as well, in fact. And this spans, of course, from theory to practice. So we often start with a practical question like, how can we improve Wikipedia for use in computer systems? But then when you go deeper, you often can get to the very bottom, to the very foundations of computer science and have questions where you have to ask, is it even possible at all on a computer to solve the problem? And so in a sense, what we are trying to achieve is to find out how far we can go on a computer with this. So one important trend people are currently looking at is what is called knowledge graphs. The goal there is to make data management more flexible and to connect existing data to other related data sources. It is then natural to view data as a graph or as a network where the link between the elements is really what matters most. And this gives rise to what we are calling knowledge graphs today. Such graphs can become very big and in general have been very successful both in research and in industry. But the challenge then is to make sense of what they really contain. If you're not very careful, in the end you end up with huge data soups that you cannot really use to solve any real problem with. I think this is a place where knowledge-based systems have a big potential to support human users to understand that data and to work with it. Nevertheless, a lot of challenges lie ahead for us there. We have to find out how to really do that and also how to bring it to the scales and sizes that we see in this field. Well, I would say some of the most innovative aspects of my research are connected to the fact that I am trying to connect humans and technology in what I am doing. So, for example, some of the largest knowledge-based systems that I have been involved with are created together with the Wikimedia Foundation that also runs Wikipedia. And there we now have systems like Wikidata where 100,000 of people are working together on a single knowledge base, which is then used by millions of other people who read that knowledge and who can benefit from that. And I think this really makes a difference if you want to design technology for this type of usage. It's not just theoretical computer science. You also have to think about how it will work with human users and experts in a certain field. Well, clearly, I think the collaboration. I think this is really unique to this place among many other places. I've seen a lot of universities, but it's very rare that people are working so closely together also across disciplines and in our case even across faculties. In the cluster of excellence we have people from electric engineering, from computer science, of course, from mathematics, and there's such an open collaborative atmosphere there which I think really creates opportunities that you do not have in other places.